For this video, we will answer all the inside activities in Chapter 9. The first activity, we will find it on page 9.1.2.1. 9.1.2.10. For us to answer this activity, we must know first what is TCP and UDP. For TCP, it is abbreviation for Transmission Control Protocol and pronounced as separate letters TCP. It is one of the main protocols in TCP/IP networks, whereas the IP protocol deals only with packets and enables two hosts to establish a connection and exchange streams of data. TCP guarantees delivery of data and also guarantees that packets will be delivered in the same order in which they were sent. TCP takes messages from an application server and divides them into packets, which can then be forwarded by the devices in the network, such as switches, routers, security gateways to the destination. Then TCP numbers each packet and reassembles them prior to handing them off to the application server recipient. Because it is connection oriented, it ensures a connection established and maintained until the exchange between the application serves sending and receiving the message is complete. Then for the UDP stands for User Datagram Protocol. It is an alternative communications protocol to a Transmissions Control Protocol, or the TCP, used primarily for establishing low latency and loss tolerating connections between applications on the Internet. Both UDP and TCP run on top of the Internet Protocol, or the IP, and are sometimes referred to as UDP/IP or TCP/IP, but there are important differences between the two. Where UDP enables process-to-process communication, TCP supports host-to-host communication. We have here different characteristics. For the TCP, less overhead, it is UDP, then connection less, fast transmission requirements, sequence message segments, no acknowledgement of receipt, no ordered delivery, guaranteed delivery, flow control, ordered delivery, then the last one, session establishment. Then for the next activity for Chapter 9, we will find it on page 9.2.1.7. We have here three choices: the ACK, Sin or ACK, then sin. CYN means synchronize, then ACK means acknowledge. It is messages indicated by either the CYN bit and the ACK bit inside the TCP header, and the SYN ACK message has both the SYN and the ACK bits turned on the TCP header. TCP knows whether the network TCP socket connection is opening, synchronizing established by using synchronize and acknowledge message when establishing a network TCP socket connections. For the SYN receive, it is both, then send, acknowledge, receive, synchronize, send, both, then receive, acknowledge. Check. And we have successfully illustrated the three-way handshake requirements of a TCP established session. Then the next activity, we will find it on 9.2.4.4. We have the TCP, UDP, and both. We must include the HTTP on the TCP as well as the Telnet, SMTP, and FTP. The next on UDP, we must include IPTV, DHCP, TFTP, then both SNMP and DNS. Now we're done answering the activities in Chapter 9.